초콜릿은 달콤해 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 오렌지는 상큼해 상큼해 상큼해.
Techniques of integration. Various techniques of integration: integration by general rule, integration by exponent form, integration by parts, integration by substitution, etc. Methods of integration. The general power formula. Integral u raised to n du is equal to u raised to n plus 1 over n plus 1 plus c, or n is not equal to negative 1. Example: integral 3 plus in 2x raised to cube over x dx. Then du is equal to 1 over x dx. Integral 3 plus 1 in 2x cube over x dx is equal to integral u cube du is equal to u raised to 4 over 4 plus k. That would be now 3 plus in 2x raised to 4 over 4 plus k. The basic logarithmic form. Integrals du over u is equal to in absolute of u plus k. Example: integral 2x cubed over x raised to 4 plus 1 dx. Let u is equal to x raised to 4 plus 1, then du for x cubed dx. Integral 2x cubed over x raised to 4 plus 1 dx is equal to 1 half integral du over u. Next, 1 half, copy 1 half in, the integral of du over u is in absolute of u plus k. So that would be now 1 half in absolute x raised to 4 plus 1 plus k. The exponential form. Integrals e raised to u du is equal to e raised to u plus k. Example: integral e raised to x fourth 4x cubed dx. Let u x raised to 4, then du for x cubed dx. Integrals e raised to x fourth 4x cubed dx is equal to integral e raised to u du, so that would be now e raised to u plus k, and the final answer is e raised to x 4 plus k. Integration by parts. Integral u dv is equal to uv minus integral u v du. Example: integrals in x dx. Our u here is equal to in x. Our dv is equal to dxv is equal to integrals u dv equals uv minus integrals v du. Integrals in x dx is equal to x in x minus integral x dx over x is equal to x in x minus integral dx, so that would be now x in x minus x plus k.
초콜릿은 달콤해 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 오렌지는 상큼해 상큼해 상큼해.
Related rate problems are differentiated with respect to time. So every variable except t is differentiated implicitly. Example: two rates that are related. Given y is equal x squared plus 3, find dy over dt when x is equal 1. Given that dx over dt is equal to 2. So y is equal to x squared plus t. Our dy all over dt is 2x dx dt. Now when x is equal to 1 and dx all over dt is equal to 2, we have dy over dt is equal to 2 times 1 times 2 is equal to 4. Procedure for solving related rate problems. First, assign symbols to all given quantities and quantities to be determined. Make a sketch and label the quantities if feasible. Second, write an equation involving the variables whose rates of change either are given or are to be determined. Third, using the chain rule, implicitly differentiate both sides of the equation with respect to t. Number 4, substitute into the resulting equation all known values for the variables and their rates of change. Solve for the required rate of change. Example, a pebble is dropped into a calm pond, causing ripples in the form of concentric circles. The radius r of the outer ripple is increasing at a constant rate of 1 foot per second. When this radius is 4 feet, what rate is the total area A of the disturbed water increasing? So, here's the given. Our dr over dt is equal to 1 when r is equal to 4. So, we should find our dA over dt. So, given equation, A is equal to pi r squared, differentiate. dA over dt is equal to 2 pi r dr over dt. dA over dt is equal to 2 pi times 1 times 4, so it will be now 8 pi. So, second example. An inflating balloon. Air is being pumped into a spherical balloon at the rate of 4.5 inches cubed per second. Find the rate of change of the radius when the radius is 2 inches. So, given dV over dt is equal to 4.5 inches cubed over sec. R is equal to 2. In, find dr over dt. Equation, V is equal to 4/3 pi r cubed. So, here's the final output. dV over dt is equal to 4 pi r squared. dr over dt, 4.5 is equal to 4 pi squared dr over dt. So, it will be now 0.09 in per second. The velocity of an airplane tracked by radar. An airplane is flying at an elevation of 6 miles on a flight path that will take it directly over a radar tracking station. Let's represent a distance in miles between the radar station and the plane. If is decreasing at a rate of 100 miles per hour, when s is 10 miles, what is the speed of the plane? So, given d is over dt is equal to negative 400. So, our seconds here is 10. So, we should find dx over dt. So, equation x squared plus 6 squared is equal to s squared. 2x dx over dt is equal to 2s ds over dt. To find dx over dt, we must first find x when s is equal to 10. So, x square root of s squared minus 36 is equal to square root of 100 minus 36 is equal to 8. So, 2 times 8 dx over dt is equal to 2 times 10 times negative 400. dx over dt is equal to negative 500. Speed is absolute value of velocity is equal to 500 mph. A fish is reeled in at a rate of 1 foot per second from a bridge 15 feet above the water, and what rate is the angle between the line and the water changing when there is 25 feet of line out? So in the above the water, it's 15 feet given. dx over dt is equal to -1. Then our x is equal to 25 feet. Then height is equal to 15 feet. Find d theta over dt is equal to equation sine theta is equal to 15 over x sine theta is equal to 15x to the power of -1. So solve. Cos theta times d theta over dt is equal to -15x to the power of -2 dx over dt. d theta all over dt is equal to -15 over 25 squared times 20 over 25 times -1. So d theta over dt is equal to -15 all over x squared cos theta times dx over dt. So copy again, d theta all over dt is equal to 3 over 100 rod per second. So that our d theta over dt. Another example. A pebble is dropped into a compound causing ripples in the form of concentric circles. The radius r of the other ripple increasing at a constant rate of 1 foot per second. When this radius is 4 feet, what rate is the total area A of the disturbed water increasing? An inflating balloon, air is being pumped